Okay, let's see here. G composed with F inverse, and then apply that to G composed F on X, for example. That should be X. That's just the definition of the inverse. So the claim is that F inverse composed G inverse, that will do for G composed F inverse. So let's see if that checks out. So F inverse compose G inverse compose G compose F of X. That should equal X. Okay, so let's apply. Yeah, I see what's going to happen here. So now, because the inverse has gone from the brackets, actually the brackets have now become redundant. F inverse compose G inverse compose G compose F of X. Does that equal X? Well, those two, one after the other, they cancel. And then those two, one after the other, they cancel. So yeah, that's true. Now we'll have to do this again, but from the other direction. So we'll have to say G compose F, compose G compose F inverse of X should equal X. Or in other words, that should be the identity mapping, that nothing takes place. That's often called that, I think, identity mapping. I of X is just X. So in other words, let's see if they cancel again. So G compose F, compose F inverse, compose G inverse. Does that equal the identity? So that's G compose F inverse, compose G inverse. Does that equal the identity? The middle two cancel. And yes, indeed, G composed with G inverse does cancel each other out, so to speak. And that is true.